Hello, dear friends, and welcome to the Statisticians again. Welcome to our video on understanding conditional probability. Probability theory is a crucial branch of mathematics that helps us analyze certain situations. While probability deals with the likelihood of events occurring, conditional probability takes it a step further by considering additional information that can influence the final outcome. In this video, we will explore the fundamental concepts associated with conditional probability to gain a solid understanding of this essential topic. So, what is conditional probability? In simple words, we can say conditional probability refers to the likelihood of an event occurring, given that another event has already happened. In simple terms, we can say it measures the probability of an outcome based on some prior knowledge or information. Before understanding the concept of conditional probability, we first need to differentiate between dependent and independent events. Dependent events are closely related to each other, meaning that the outcome of one event affects the probability of the other event occurring. For example, let's consider drawing two cards from a deck of 52 cards without replacement. If the first card drawn is an ace card, the probability of drawing a second ace will be different than if the first card was not an ace card. Basically, the removal of the first ace affects the sample space and therefore influences the probability of drawing another ace. Now let's talk about independent events. Independent events as compared to dependent events are not affected by prior events. It means that the probability of one event occurring does not influence the probability of the other event happening. For instance, if we toss a fair coin 2 times, the outcome of the first toss has no impact on the outcome of the second toss. Each toss is independent and unaffected by the previous results. Now let's talk about sample space and outcome. The term sample space refers to the set of all possible outcomes of any experiment. Each outcome in the sample space has a specified associated probability. Understanding the sample space is essential when calculating conditional probability. While outcome represents a specific result within the sample space. For example, when rolling a fair 6-sided die, the sample space consists of outcomes from 1 to 6, and each single number is considered an outcome. Now let's see how to calculate conditional probability. The formula of conditional probability is probability A given B is equal to probability A intersection B divided by probability B, where probability A given B denotes the probability of event A occurring given that event B has already happened. On the other hand, probability A intersection B represents the intersection of events A and B, that is, the probability of both events occurring together. Probability B represents the probability of event B occurring initially. By calculating these values, we can determine the likelihood of event A happening in light of event B. Conditional probability is very important. It helps us analyze real-life situations where outcomes are influenced by prior events. Understanding this concept is essential in various fields such as statistics, economics, and even everyday decision making. By considering conditional probability, we can make more informed choices and predictions based on the given circumstances. We hope this video has provided a comprehensive understanding of conditional probability. Remember that probability theory is a fascinating subject with endless applications. Stay curious and keep exploring the fascinating world of mathematics.